Disjunction means false and false is false. In all cases, it is true. What is the inverse? Suppose if P is conditional to Q, this is the conditional statement. So the inverse of this is negation P conditional to negation Q is called the inverse. P disjunction Q. They are logically equivalent because the truth values of fifth and sixth column are same. So they are logically equivalent. Hello dear students, welcome to this session of Basic Mathematics Revision class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding very easiest chapter, that is mathematical logic. So in this chapter, you are going to get one MCQ question, that is 1 mark 1 question and one 5 marks question. So usually the 5 marks question is the construction of the truth table, and 1 mark question is a simple problem. So that is from MCQ part. Now 1 mark plus 1 mark plus 1 5 marks, totally 6 marks is the weightage for this chapter. Now move on to the first question. So 1 mark question, negate the following. So negate the proposition P conditional to negation Q. So we have to negate this, negation of P conditional to negation Q. So if you negate this, what we will get? So this is nothing but P conjunction negation of negation Q, that's equal to P conjunction negation of negation is Q itself. So P conditional to negation Q is nothing but P conjunction Q, that's it. Okay, now move on to the next problem. Negate the proposition 4 is an even integer or 7 is a prime number. So the statement is given. What is given? 4 is an even integer or 7 is a prime number. So what is given? So here this is P. P is nothing but 4 is an even integer. 4 is an even integer. Then Q, what is Q? Q is nothing but 7 is a prime number. 7 is a prime number. This is given, P and Q. So what is given? Given that P or means this is nothing but disjunction, P disjunction Q. This is P disjunction Q. Now we have to negate this. Negation of P disjunction Q is equal to, so this can be written as negation of P conjunction negation Q. So therefore what is the negation? So that means negation of P is 4 is not an even number. 4 is not an even number, and conjunction here, and 7 is not a prime number. This is the negation for the given statement. So that is negation of P conjunction negation Q. That means 4 is not a even number and 7 is not a prime number. That's it. So here instead of a number we can also take integer. So you can also write 4 is not an even integer and 7 is not a prime number. 4 is not an even integer and 7 is not a prime number. That's it. Now move on to the next one. Write the inverse for the proposition if x into x minus 2 is equal to 0, then x is equal to 2. What is the inverse? Suppose if P is conditional to Q, this is the conditional statement. So the inverse of this is negation P conditional to negation Q is called the inverse. So what is given here? This is P, right? P and then Q. What is P? We have P is nothing but x into x minus 2 is equal to 0. What is Q? Q is nothing but x is equal to 2. This is given. Now negation of P conditional to negation Q. So therefore the inverse of the given statement is inverse is if x into x minus 2 is not equal to 0, then x is not equal to 2. X is not equal to 2. That's it. This is the inverse. That's it. So if x into x minus 2 is not equal to 0, then x is not equal to 2 is the inverse of the statement. That's it. Right. Now move on to the next one. Symbolize the proposition 2 plus 5 is equal to 6 or all integers or rationals. We have to symbolize this. Here what is given? Symbolize the proposition. This is P. 2 plus 5 is equal to 6. All integers are rational. This is Q. So we can write P is nothing but 2 plus 5 is equal to 6. And what is Q? Q is nothing but all integers. All integers are rationals. This is the given statement. So the proposition 2 plus 5 is equal to 6 are all integers are rationals. Now what is to write here? Symbolization. What is the connective we are used here? Or disjunction. So we can write P disjunction Q. That's it. P disjunction Q. Okay. So this can be written as P disjunction Q is the symbol. That is 2 plus 5 is equal to 6 or all integers are rational. Suppose if it is and means we are going to use the conjunction. Now move on to the next one. Symbolize the proposition if oxygen is a gas then gold is a compound. So here the statement started with if and then. If then means this is nothing but the conditional statement. This is P and this is Q. What is P here? P is nothing but oxygen is a gas. And what is the Q statement? Q is nothing but gold is a compound. So what is the condition given? If then means that is nothing but P conditional to Q. That is P conditional to Q is the symbol. That is if oxygen is a gas then gold is a compound. So the symbolic representation of this is P conditional to Q. That is a conditional statement. Right. Now move on to the next one. So now let us discuss 5 marks questions. So examine whether the proposition P conjunction negation Q disjunction Q and P disjunction Q are logically equivalent. So we have to verify whether these two statements are logically equivalent. So that is to prove, what is to prove? P conjunction negation Q disjunction Q is logically equivalent to P disjunction Q. So to prove that, to verify that whether these two are logically equivalent. Now let us construct the truth table for this. First, now PQ negation Q, P conjunction negation Q, again P conjunction negation Q disjunction Q and P disjunction Q. So write down the truth values for this. T, F, F, T, F, T, F. Now what is negation of Q? True, it is false. For false it is true. For true it is false. For false it is true. Now conjunction of these two. Conjunction of P and negation Q. Conjunction means true and true is true. In all cases it is false. True and false is false. True and true is true. False and false is also false. False and true is equal to false. So conjunction of P and negation Q. So true and false is false. True and true is true. False and false is false. False and true is also false. Now just write down the disjunction for P conjunction Q, P conjunction negation Q and this Q. So for these two write down the disjunction. Disjunction means false and false is false. In all cases it is true. So false and true is equal to true. True and false is also true. False and true is also true. False and false is equal to false. So disjunction, false and false is false. In all cases it is true. So false and true is true. True and false is true. False and true is true. False and false is equal to false. Now write down the disjunction for P and Q. True, for disjunction false and false is false. In all cases it is true. So true and true is true. Again true and false is also true. False and true is also true. False and false is equal to false. Now check these two columns. Let us represent this as 1, 2, 3, 4, 5 and 6. If you observe carefully, all the truth values in 5th and 6th column are same. TT, TT, TT and FF. So therefore 5th and 6th column have same truth values. So therefore they are logically equivalent. So therefore we can write P conjunction negation Q disjunction Q is logically equivalent to P disjunction Q. They are logically equivalent because the truth values of fifth and sixth column are same. So they are logically equivalent. Now move on to the next problem. Verify whether the proposition negation P negation of P conditional to negation Q disjunction negation P biconditional to Q is a tautology. So we have to verify whether this is a tautology, contradiction, or neither tautology nor contradiction. So if we get all the truth values for the given combination as T, 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 then it is called a tautology. If it is F and F, 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 then it is called a contradiction. If we get true F, true F, then it is neither tautology nor a contradiction. Now let us split this. So P, Q, negation Q, P conditional to negation Q, negation of P conditional to negation Q, and negation P, negation of P biconditional to Q, and the disjunction for these two A and B. Now what are the truth values? True, true, false, false. This is true, false, true, false. Negation of Q. So for true it is false, for false it is true, for true it is false, for false it is true. Now conditional. Conditional for these two, that is P and negation Q. Conditional means true and false is false. In all cases it is true. True and false is false. True and true is true. False and true is also true. False and true is also true. Now the negation for P conditional to negation Q. So first P conditional to negation Q, the conditional for these two, true and false is false, true and true is true, false and true is false and false is true, false and true is also true. Now write down the negation for this. So negation for false is true, for true it is false, for true it is false, for true it is false. So negation of false is true, true, false, true, false, true, false. So now just write down the negation of P. Negation of P is false, false, true, true. Now write down the biconditional for negation P and Q. So the biconditional for these two, negation P and Q. So for biconditional, true and true is true, false and false is also true. In other cases it is false. So biconditional between false and true is false, false and false is true, true and true is also true, true and false is equal to false. Right. Now write down the disjunction for these two. Disjunction. So in case of disjunction, false and false is false. In all cases it is true. So true and false is true, false and true is also true, false and true is also true, and then false and false is equal to false. Right. What do you say? This is neither a tautology nor a contradiction. That's it. Yes. So here, therefore, it is neither tautology nor contradiction. Right. This is neither tautology nor contradiction. Suppose if we get all the truth values as T, 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 then it is tautology. If we get all the truth values as F, 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 then it is contradiction. Since it contains T, T, T and F, so therefore this is neither tautology nor a contradiction. Right. Now move on to the next problem. Prove that P disjunction Q conjunction negation P conjunction negation Q is a contradiction. So we have to verify this is a contradiction. Now just construct the truth table for this. P, Q, P disjunction Q, negation P, negation Q, negation P, conjunction negation Q, and the conjunction for A and B. So write down the truth values T, T, F, F, T, F, T, F. Write down the disjunction. So disjunction means false and false is false. In all cases it is true. True and true is true. True and false is true. False and true is also true. False and false is false. Now write down the negation of P. Negation of P. For true it is false. For true it is false. For false it is true. For false it is true. Negation of P. F, F, T, T. Next. Negation of Q. Negation of for true it is false. For false it is true. For true it is false. For false it is true. F, T, F, T. Now, write down the conjunction for these two. Conjunction for negation P and negation Q. So, conjunction is true and true is true. In all cases, it is false. So, false and false is false. False and true is also false. True and false is false. True and true is true. Conjunction. Now, write down the again conjunction for these two. P disjunction Q, conjunction negation P, conjunction negation Q. Write down the conjunction. Conjunction means again true and true is true. In all cases it is false. So true and false is false. True and false is false. Again true and false is false. False and true is also false. So what do you say? All the truth values for this combination are F, 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 F. So therefore this is a contradiction. So therefore it is a contradiction. That's it. So all the values in the last column are F, 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 F. Therefore the given statement is a contradiction. Suppose if we get all the values as T, 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 then it is called a tautology. This is how we are going to verify whether the given compound statement is a tautology or a contradiction or neither tautology nor a contradiction, right? So to verify whether the given statement is a tautology, contradiction or logically equivalent, so you must be familiar with the construction of the truth table for conjunction, disjunction, conditional, biconditional and negation. So let me repeat, for conjunction true and true is true, in all cases it is false. So for a disjunction, false and false is false, in all cases it is true. For a conditional statement, true and false is false, in all cases it is true. Whereas for biconditional statement, so true and true is true, false and false is also true, true and false is false, false and true is false. And for negation of the given statement, for negation, if it is true, then you will get false, for false it is true. So once if you know the construction of truth table for conjunction, disjunction, conditional, biconditional and negation, you can solve any problems related to tautology, contradiction or logically equivalent. So you will get 1 5 marks question from this concept. Hope you followed. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.